This is the abstraction. Hmm. Hmm. Abstraction is a way of hiding unnecessary details and showing only the essential features of an object or system. Okay. Hmm. That's fine. Abstraction in C++ simplified in abstraction. This is this. Abstraction is a way of hiding unnecessary details and showing only the essential features of an. Okay. Hmm. Mhm. This is razor. Right. Hmm. So this is abstraction in C++. This software is new for me, so it's taking just few minutes to me to get understand. The abstraction is a way of hiding unnecessary details and showing only the essential features of an object or system. It helps focus on what a system does rather than how it does it. Fine. So I should write this. Abstraction is a way of hiding unnecessary details and showing only the essential features. The essential features, yes, yes, of an object or system. Hmm. So key points simplifies complex systems. By ignoring the irrelevant details, abstraction makes complex systems easier to understand and work with. Simplifies complex system. By ignoring the irrelevant details, abstraction makes complex system easier to understand and work with it. Okay. And then real life analogy. Think of a car. You can see the steering wheel, pedals, and dashboard. Essential details. You don't see the internal engines, mechanics, or wiring. Okay. In C++, abstraction is achieved through abstract classes, and interface. You define what actions an object can perform without specifying how the actions are implemented. Data binding, what it is. The process of linking data in the application's UI user interface to the business logic in the backend. Okay, so this is the code for the abstraction in C++. Here is an example of abstraction using an abstract class. Include IOStream. Okay, this is a library for C in and C out. Okay, then using namespace std. Okay, class shape. Okay, this is a shape. This is a class whose name is shape, and this is public. Okay, its access is public. Virtual void draw is equals to 0. Why they have used virtual void? Fine. Pure virtual function, no implementation. Okay, okay. Virtual is something for abstract, I think. I think yes. Class circle. This is a different class whose name is circle, and this is public again. Okay. Shape public draw void draw override. See out drawing a circle in L. Class rectangle public shape public void draw override draw a rectangle. Okay. Draw a rectangle. Wait a minute. What is this? Get out. Class rectangle public shape void draw override see out this thing. Okay, int main shape star shape one. Okay. How this example shows abstraction. Abstract class shape defines what draw method must exist in derived classes. Hides this how. Okay, the implementation output is this. Wait. Uh, explain explain me the code. Explain the code with line by line by line with uh, with meaning of syntax like why this syntax is used and what is what it is what it is yeah what it is doing. Fine. Hmm. Line by line explanation of the code. Yes, this is I know. This I know. Include IO stream is using namespace std. Include IO stream includes the input output library in C++. Mm-hmm. There I know. Need to use cout or for output and cin for input. Using namespace std allows direct use of standard library objects like cout, cin without prefixing them with std. Oh, okay. Okay. This is what Laksha was telling me before. Okay. This class shape, hmm and this is public class shape defines an abstract class named shape. A class is a blueprint that describes data and functions. Okay, attributes and methods. So, what is class? Class is a blueprint that describes data. It is describing the data and the methods and the functions used. Okay, public access specifier. Okay, members declared under public can be accessed from outside the class. Virtual void declares a pure virtual function. What it does, the draw function must be implemented by any class derived from shape. Is equals to 0 makes the function pure virtual, turning the shape class into an abstract class. Shape class into an abstract class. Okay, abstract classes cannot be instantiated directly. Mhm. Explain me this part why virtual is used why virtual is used. I understood void void virtual is used virtual and by virtual and this thing void no draw is used. I understood void. Okay, fine. Hmm. Explanation virtual void is equals to 0. This line declares a pure virtual function in the shape class. Okay, let's break it down. What does virtual mean? Virtual in C++ that allows a function to be overridden in a derived class. Okay, When a function is marked as virtual in the base class, the correct version of the function is determined at runtime, not compile time. What is this? This enables polymorphism, which means you can use a base class pointer or reference to function. Y u is equal to 0. Y u is equal to 0 makes the function a pure virtual function, meaning it must be implemented by any derived class. Okay, the base class shape in this cannot implement for the draw function. Okay. So basically this pure virtual function means it can be used only by derived class. See, it is written here, it must be implemented by any derived class. The base class shape in this case cannot have an implementation for the draw function. The class becomes an abstract class which cannot be instantiated directly. Okay, fine. What is draw? Draw is a placeholder function that defines in the base class. Okay, it represents an action that any shape like circle or rectangle must perform but does not specify how. It represents a function that any shape. Okay, each derived class will provide its own implementation of draw. Okay, coming back to the code. Going back to the code, and here it is. Yes, still here I did. Now this one part. Class, circle, public shape, public, void, draw, override. Okay, C out, and L. So C out I know, and L I know. C out this and L. Okay. So here class circle, public shape, this thing. Declares a class circle that inherits from shape. Okay. So this is how we did for inherit. We inherited the function shape. Okay. Declares the class circle that inherits from shape class. Okay. Good. Inheritance means circle gets all public and protected members from shape. Inheritance means circle gets all public and protected members of shape. That is what inheritance means. Yes, this is the pillar of oops. This is one of the pillars of oops. Okay. So we have void, yes, draw, override. Then we have implements the draw function declared in the shape class. What is this bit? Implements the draw function declared in the shape class. Shape class. What is this? This is okay. Class circle public shape declares a circle. Class circle that inherits in the shape class inherits. Okay, fine. Void draw override implements the draw function. Okay, function declared in the shape class. Shape class is the first class that we have made. Override. Override keywords ensures that the function overrides a virtual function from the base class. Okay. Override keyword ensures this function overrides a virtual function from the base class. So virtual function I know. Okay. C out, that is drawing a circle. Okay. Outputs the string. Drawing a circle to the console, and L inserts a new line after the output. That I know. And then we have this thing which is for the rectangle. This is the class for the rectangle. Again, it is inheriting the what methods and wait. Yeah. It's all public and protected members. Yeah, members from the shape. Rect class rectangle is inheriting all public all public and protected members of shape class, and then public we have void draw override. Again, this is same like that what we have seen in circle. Void draw override. Similar to the circle class, rectangle inherits the shape from the rectangle inherits from shape, that is shape class, and implements its own version of the draw. Outputs: drawing a rectangle when called. Okay. Int main shape star new circle shape star shape equal to new rectangle. What is this? What is this? Yeah, this is what I want to learn. Entry point of the C program. Int main shape star shape is equal to new circle. Okay. Creates a pointer to the shape. Creates a pointer to the shape. Achha. Class shape star shape 1. What is this? Wait. Creates a pointer to the shape. To the shape class. Okay. Okay. Shape class. Shape star shape 1 dynamically allocates memory from a circle object using new. What this means? Dynamically allocates the memory for a circle. Circle is there. Yes. Okay. So it is dynamically allocating memory for a circle by using okay object using. I don't know what exactly it means. Fine. We'll see. Then we have polymorphism. Polymorphism. Since shape has a virtual function, yes, the correct draw implementation circle will be called at runtime. Wait, since shape has a virtual function, shape. Yes, shape the first class that we have made. Okay, virtual function it has the virtual function. The correct draw. Wait, I got something. Hmm. Creates a pointer to the shape class. This thing, fine, I got it. Dynamically allocates memory for a circle object using new. What is this? Dynamically allocates memory for a circle. Okay. Yes. Polymorphism, since shape has a virtual function, yes, the correct draw implementation circle will be called at runtime. Okay. Shape star shape 2 equal to new rectangle, new circle. Okay. Similarly creates a shape pointer pointing to a rectangle object. Drawing a circle, drawing a rectangle. Calls the draw function from the circle object. Okay, the correct version is determined at runtime because of runtime polymorphism. Delete. Okay. So for this, wait. Mhm. For this code, give me the output. output and explain it as well. Hmm. Hmm. Drawing circle, abstract class. Okay. Pure virtual function, derived class, circle, inherits from shape, fine. Derived class, rectangle, yes. Main function, okay. Polymorphism in action. Polymorphism, I don't know what it is. I will see. Soon I will see that. I guess after this, polymorphism is there. Yes, polymorphism. And then all this. Okay, fine. Hmm. Hmm. Okay, so polymorphism in action. Shape star shape 1 new circle. A shape pointer shape 1 points to a circle object. Okay, when shape 1 greater than greater draw. Okay, when shape 1 draw is called, the program uses circle class. Okay, fine. Wait a minute here, let me complete this so that I can understand what it is exactly means. This shape star, the shape pointer, which shape pointer, shape 1, shape is the first class, okay, points to a circle object. Circle is the second class, okay. When shape 1 draw is called, the program uses a circle. This program uses the circle. Wait, I'm coming. Let's continue. So I have abstraction. Abstraction, yeah, and then abstraction. Hmm. Till here I got shape 1. When shape 1 is draw is called, the program uses circle class draw function because the function is virtual. Okay, shape pointer shape 2 equals new rectangle. This a shape pointer shape 2 points to a rectangle object. When shape 2 this is called, the rectangle class draw function is used. Okay, memory cleanup. Delete shape 1 and delete shape 2. Okay, free the dynamically allocated memory for circle and rectangle. Abstraction, polymorphism. So the shape class defines the concept of shapes and their ability to draw without specifying how. Fine. The details are handled by circle and rectangle classes. Wait a minute. Wait a minute. Wait a minute. The details are handled by circle and rectangle classes. Polymorphism. The shape pointer calls the correct draw function based on the type of the circle or rectangle it points to. The decision is made at runtime. This as I don't understand. Fine. Uh, Now I will be moving on to the polymorphism part. So this is the polymorphism, compile time polymorphism, and one more was there, runtime polymorphism, runtime. Yes. So this is polymorphism, and I'm going to do it like this. Polymorphism. Hmm. Poly means many and morphism means forms. Okay. It allows the same code to behave differently depending on the context, making it flexible and reusable. Polymorphism is a feature in object-oriented programming that allows a single interface, okay, to work with different data types or behaviors. Single interface, which are like function or class, okay, to work with different data types or behaviors. Okay, fine. Types of polymorphism. Polymorphism is compiled time polymorphism. Okay, compiled time polymorphism, and then what we have runtime polymorphism. You have to explain the code, but you guys are like, fine. Let me understand. Let me try to understand this. Then I will be doing that. Hmm. Types of polymorphism. Leave this at 5 p.m. because I have an exam at 6 p.m. Okay, so what is this? Compiled time polymorphism. That is static polymorphism. Wait. Okay. Decided during the compilation of the program. Achieved using method overloading or operator overloading. Example: a function with same name but different parameters. Wait, I didn't get it. Polymorphism is the ability to present the same interface for differing underlying forms, that is data types. With polymorphism, each of these classes will have different underlying data. A point shape needs only two coordinates, assuming wait. A circle needs a center and radius. Square or rectangle needs two coordinates for the top left and top right corners and possibly a rotation. An irregular polygon needs a series of lines. Precisely, poly means many and morphism means forms. Something is there. I didn't get it exactly. So we have types of polymorphism, that is, which is important: compile time polymorphism, static; runtime polymorphism, dynamic. Once again, polymorphism is the ability to present the same interface for differing underlying forms. Okay, with polymorphism, each of these classes will have different underlying data. Each of these classes, this class, all the classes will have different underlying data. Different underlying data. I don't know what is this. A point shape needs only two coordinates. Okay, assuming it's in a two-dimensional space, of course. A circle needs a center and radius. Yes, a square or rectangle needs two coordinates for the top left, and bottom right corner, and possibly a rotation. Okay, an irregular polygon needs a series of lines. Fine, I got it. Whatever it is. So we have compile time polymorphism. The polymorphism which is implemented at the compile time is known as compile time polymorphism. Example: method overloading. Method overloading is a technique which allows you to have more than one function with same function name but with different functionality. Method overloading can be possible on the following basis. Mm, the return type of the overload function. Wait a minute. Return type polymorphism constructor. Destructor. This pointer. Your virtual function. Abstract classes. Namespace std. Private, public, proctored, protected, delete, virtual inheritance, function overloading. Compile time polymorphism. The polymorphism which is implemented at the compile time is known as compile time polymorphism. Example, method overloading. Now we have method overloading. Method overloading is a technique which allows you to have more than one function. Have to more than one function with the same function name. Okay, but with different functionality. Hello? So we have method overloading is a technique which allows you to have more than one function with the same function name but with different functionality. Method overloading can be possible on the following basis. The return type of the overloaded function, okay, the type of parameters passed to the function, the number of parameters passed to the function, okay. Example, include this, okay. Class, there is one class whose name is add. Okay, there's a class whose name is which is called as add, and it is public. Access specifier is public. Int add, int a, int b, return a plus b, okay. And then int add, int a, b, c, return a plus b plus c. Int main, add object, okay. Int res1, int res2, res1 is object, add 2 3 4, okay. res2 is object, add 2 3 4. Wait, res1 is add 2 3 and res2 is obj dot add, okay. I got it. Count res1, then this, okay, then res2 and l return 0. Output, what is this? Output 59. What is this output 59? Add is an overloaded function with different number of parameters. Add is an overloaded function with a different number of parameters. Okay, fine. And then we have runtime polymorphism. I'm still blank about what is polymorphism. Runtime polymorphism is also known as dynamic polymorphism. Okay. Function overriding is an example of runtime. Function overriding is an example of runtime. I have to see runtime polymorphism. Runtime polymorphism. Function overriding means when the child is an example of runtime polymorphism. Function overriding means when the child class contains the method which is already present in the parent class, hence the child class overrides the method of the parent class. Okay. In case of function overriding, parent and child classes both contain the same function with the different definition. The call to the function is determined at runtime is known as runtime polymorphism. So this is the code. Yes, this is the code. So include using namespace std class base class. Okay, okay. This is the name of a class. This base class. It's what access specifier is public. Virtual void again. Virtual is here. So I think virtual is for something. I forgot. Virtual is to like it's pure virtual. It cannot be, yeah, virtual class. Virtual function is the function which cannot be used by its own class, but it can be used by its derived class. Yeah, by the class is derived by that class. Virtual function can be used, but the class which is having virtual function, it cannot use that virtual function. Fine. This is the main whatever you say definition or something for virtual void. Okay, cout is written as apni kaksha base and L. Okay, then class derived class public base class. Okay, okay, public base class and then public void show cout. This derived in int main base class star b derived class d. B is equals to this d. B show uh, prints the content of show declare in the. That's it. Constructor destructor, not very much is there. Hmm. Fine, but I have to do so. Just now. Hmm. Explain me the polymorphism with different examples. Explain the more polymorphism with different examples. But wait. Explain the polymorphism in simplest way with different examples. Good. Polymorphism in simple terms. Polymorphism allows the same function, object, or method to work differently depending on the context. Think of it as one name, many forms. One name, many forms. Okay. Types of polymorphism. Wait a minute. Wait a minute. Let me write this as well. So this is polymorphism. Polymorphism allows the same function. Allows polymorphism allows the same function. Okay, the same function. Mm-hmm. Comma object. Mm-hmm. Or method. Mm-hmm. To work differently. To work differently. It can work differently. Okay, depending on the context. Okay, think of it as one name, many forms. One name, many forms. I got it. I got it. So basically, polymorphism is something uh, which allows this function, object, or method to work differently depending on the context. Whatever the context is, on the situation, on the basis of on depending upon the context, it can work with the same function with the same object. So basically, same function, objects, and methods work differently. Can work differently. Depends on the situation. What is the situation? Okay, types of polymorphism. So we have types of polymor polymorphism. Types of polymorphism. So we have here is compile time polymorphism. That is static. Decided at compile time. Wait, wait. Yeah. Definition is decided at compile time, meaning the behavior is determined before the program runs. Okay. How? Achieved using method overloading or operator overloading. Method overloading, operator overloading. Okay. Compile time polymorphism, that is static. Compile time polymorphism. I am writing as well and I am dictating myself as well. So this is the definition. Definition. Definition is decided at compile time. Decided at compile time. This what is this? It gets decided at the compile time. Compile time, meaning the behavior is determined before the program runs. Meaning the behavior is is determined is determined before the program runs. Good, good. And then we have how. Achieved using method overloading or operator overloading. Achieved, yes, achieved using method overloading. What is method overloading? I don't know. Overloading and sorry, or operator overloading. What is overloading? Is it that overloading like what truck drivers do? They just overload their trucks. Fine, we'll see. Method overloading using the same function, the name using the same function name but with different arguments. Function name is same but arguments are different. Okay, this is method overloading. So I have method overloading. Method overloading using the same function but with different arguments. Include IO stream using namespace std. Okay, class it is calculator. So we have this public. What public? You have to say it is. If I forgot, I forgot. Access specifier. Yes, access specifier is public. Then we have int add int a int b return a plus b. Okay. Then we have int add int a int b int c return this. Okay. Int main calculator. Mm-hmm. Int main calculator cal. Hmm. C out is this. C out is this. Okay. And sum of this. So it is going to print this. Okay. From calc add 2, 3 and n. Okay. Calls first add, calls second add. So calls the first add and then calls second add. Okay. Output is this. Operator overloading. Changing how operators work for user defined types. Okay. So again this is complex. Class name is complex. And then this is public. Public what X is specified. Yes. Int real comma image. Okay. Complex int r, int I, real r, image I. Wait, let me write this first, then I will move to that. And one more thing, they have also written this, right? This is a method overloading. Yes. Using hashtag include what IO stream. Just me raising IO stream. So here what they were doing, yeah, using namespace std, using name space std, and then we have class add. The name of the class is add. Its access specifier is public. Okay, after this we have int add, int a, okay, int b, okay, return a plus b. Okay, fine. Return a plus b. Then we have one more function, int add, int a comma, int b comma, int c. Right? Again we have return a plus b plus c, and then closing this. Fine. After this I have, what is this? Oh, how I know what is this? Just tell me what is int. There is int main, int main. Okay. This is add object. It is making something. So add obj int res1 res2, because those whatever you will add int a and b, it will store in res1 res2. Okay, int res1 comma res2. Okay, then we have res1 is equals to this, res2 is equals to this, object dot add. So it is calling that function. I think yes, correct. And res1 and res2, and res1 comma res2, res1 is equals to object dot add 2 comma 3, and then res2 object dot add 2 comma 3 comma 4. Good, good one. Then we have c out. Okay, c out is this much. Okay, so c out res1 res2 res2 and l return 0. Hmm. Return 0. Then we have output 5 comma 9 add overload function. What is this? Overloaded function with a different number of parameters. I don't know about this. Come to the runtime parameter. Runtime polymorphism. I'm so sorry. Runtime polymorphism. Runtime polymorphism is also known as dynamic polymorphism. Function overriding is an example of runtime polymorphism. Okay, function overriding means when the child class contains the method. Wait. When the child class, yes, contains the method which is already present in the parent class. Okay, function overriding means when the child class, I know what is child class, contains the method which is already present in the parent class. It is already present in the parent class. That one. Hence, the child class overrides the method of the parent class. Okay. In case of function overriding, parent and child classes both contain the same function with a different definition. Okay, the call to the function is determined at runtime is known as runtime polymorphism. Oh, okay. The call to the function is determined at the runtime is known as fine. Coming to this thing, coming to the chat GPT. Uh, is this the same example they are using here? No. No. Changing how operators work for user-defined types. Runtime polymorphism. Include IO stream. Runtime. Where I am. Am I the correct place or not? Added method overloading. I have to do this thing, yes. So here I have changing how operators work for user-defined types. Okay. Here is include IO stream using namespace std. Class name is complex. There it is written as public. Okay, this is the X specifier. Int real image complex int I real r image I. Okay, overload the overload the operator complex operator plus constant. What they are doing here, what they are doing, please. For runtime polymorphism, give simple code and its detailed explanation. Hmm. I think I got it. Hmm. This is the detailed code. I what I gave the command, give the simple code and its detailed explanation. Fine, okay. Base class is animal. So here they are defining that class with specifier public virtual void sound. See out, this is general animal sound and okay. Hmm. Okay. Virtual keyword. What is virtual keyword? Declares the sound function as a virtual function. Ensures the correct sound function from the derived class is called at runtime. Wait. Ensures the correct sound. Okay. Function from the derived class is called at runtime, even if accessed through a base class pointer. Base class pointer. Okay. Okay. Derived from the function from the derived class ensures the correct sound function from the derived class is called at runtime. It is it is calling from derived class even if access through a base class pointer. Base class pointer. Base class is the first one class and the derived class is the classes which are derived from the base class. So basically it is saying ensures the correct sound function from derived class is called at runtime. So basically at runtime, okay, fine, I got it. What this does, if sound is not overridden or in a derived class, the base class implementation will be used. Mm, ensures the correct sound function from derived class. Ensures the correct. Okay. If sound is not overridden in the derived class, the base class implementation will be used. Okay. Derived classes dog and cat. Hmm. Class dog, rest the public animal public Okay. Then we have void sound override. What was here? Virtual void sound override. Okay. Hmm. Overrides the base class sound function. Hmm. Override keyword optional but ensures you are correctly overriding a base class function. Similarly for cat, class cat, public animal, public, void sound override, cout, cat meows, and l. Okay, main function. Int main, animal pointer, animal, base class pointer. Good. Dog, dog, cat, cat, dog, dog, cat, cat. Okay. Animal is equals to this pointing to dog object calls the dog's version of sound. Animal equals to pointing the dog object. Okay, so dog object we created here. We created here. Hmm? And then the cat function we created here. So we have dog, dog, cat, cat, animal, animal. What is this man? Equal and dog pointing to dog object. Animal sound calls dog version of sound. Animal equal and cat pointing to cat object. Animal sound calls cat's version of sound. Return 0. I don't know what this shit is. What is this shit? But fine, something I catched. Something I call base class pointer animal. Okay, a pointer of the base class type can point to any object derived from the base class. Okay. Okay. This allows a single pointer to work with multiple derived types. Correct? Correct. It's a good one. Dynamic binding. When animal this sound is called the program decides at runtime which sound implementation to use based on the actual object animal points to. If animal points to a dog, object dog sound is called. If animal points to a cat, object cat is called. Okay, so here this is this. So I think for this it is doing this. Dog barks, cat meow. Why use runtime polymorphism? Flexibility, reusability, and something. Why use runtime polymorphism? Flexibility. A sing- that is not a point, yeah. That is not a point. I've got a mail from Deloitte. What? Polestar, 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 Polestar.